Hey everybody, we're going to start our fall 2022 semester for statistics with the actual lecture portion. I know the first week was for doing some stuff on time management, different projects like that. Let's get started on a lecture. We're going to be covering a lot of chapter 1 today. Good portion of it. It's the boring part for the most part. See if I can get this lined up right. And so you might be wondering, well, what the hell is statistics? Why are we here? What is this class about? So not just businesses, but it's useful to know what the population wants or is doing or what makes it up. And we do this a lot for people, but this applies to a car, like all of the specific type of car, all the apples in the country, things like that. It doesn't have to be people, is my point. But if we're like, people is the easiest one to use. Think of all the data that's collected when you're on Google and you're surfing and checking out what you want. You start getting advertisements by companies that you like. I don't know if you've done this. When I bought a new refrigerator, this is probably not usual for some people, but picture something you bought new that was kind of inexpensive, and then got ads for it for the next 6 months that you could buy it. They've done data collection on that. And that's targeted ads and stuff like that, where it has to be specific to you. But in some circumstances, they don't need to know what each individual wants. It's more helpful to know what everybody in the state wants. Like when you're looking at politics, what does everyone in the state want? Well, we got a lot of people. There are a lot of people. There's a lot of people in Visalia and Tulare alone, let alone Tulare County, let alone the state of California, the U.S., the world. We can't realistically go ask all of them. We try. Every decade, we have what's called the U.S. Census. They send people door to door to collect information on who lives there, how old everybody is, what kind of jobs you're doing, what's the income. But they can't do all the houses at once. So even if they're just doing Visalia and they start on the west side of Visalia, by the time they hit every house and they've gone to the eastern side of Visalia, a couple months have passed and new people have died and new people have been born. And so like what started when they began on the west side is no longer accurate by the time they get to the east side. So even the census is inaccurate. So what do? How do we figure out what's going on in a county, a city, a state, something like that? That's what statistics are for. We go out and we collect information from a group of people in that area. And we try to make it as a random of a group as possible so that it represents the city. So they might hit only one in every 10 houses. If you were trying to figure out a city but didn't want to ask every door to door, you could do once on every 10 houses, or hit people going in and out of malls and stuff like that. Or since we do a lot of online shopping now, that might not be as good, but maybe surveying people going in and out of restaurants or something like that. Supermarkets, we still shop for groceries. People will survey there. Even then, if you wanted to collect data, and let's say you get 1,000 people, 2,000 people to give you information, well, what do you do with it? Like if we're collecting information in a grocery market and we're talking about what kind of purchase you make, some people are buying milk, some people are not buying milk, some people are buying meat, veggies, stuff like that. So what do they do with this information? Well, that's what statistics is about. And so uh, let's just describe what goes on in general in statistics and start from there. Generally, what they do with statistics, I'll give you an official definition in a second, but it's more handy to think of what's going on. Generally, we want to know something. That is a very, very vague sentence. We want to know something. Let's say about a population, and that's not necessarily people. Asking every individual is not useful, so we survey. Well, it is useful, but it's not practical. It is not practical due for time constraints, time reasons, money. Think about how much you got to pay people to go house to house in Visalia, to knock at the door, wait for an answer, talk for 5 or 10 minutes to get information for the U.S. Census. Those people aren't doing it free. It takes money. So time, money, manpower, different kinds of things like that. It's asking every individual is not useful or practical, really. So we will survey a subset or group from the population. And this group is called the sample. So if I were trying to find out the people in Visalia and I asked people at the grocery store, the people that I asked at the grocery store would be my sample of the population of Visalia. Generally, what you're looking at for this group is they have similar traits. Group has similar traits. That you're doing. Like, let's say you wanted to see how Visalians were going to vote on the next election. We don't even need to go with politicians. Local laws. Right now, COS is considering asking for funding, asking the taxpayers to support a project where the western side of the COS campus becomes a university zone for, I want to say, a CSU Fresno extension, where you can get a 4-year degree within, a football field away from COS. It costs money, so they're going to ask the people if they're willing to support it on an upcoming thing. And they don't know how it's going to turn out, so they're going to go out and ask people, try to get an idea of what the answer is going to be. That way they don't waste money even asking if everybody says no. The similar trait here is that they're all Visalians. You're asking people in an area. So that's really the first step. First step that we're doing in statistics, we're trying to answer a question. And the question is generally something about a population. So step one, we call that thing a research objective. We're going to identify a research objective and its population. And then that's the whole, we want to pay for a new university 4-year satellite campus here. Then we don't know if people are going to support it, so we conduct an experiment to collect data. And this is kind of what chapter 1 is going to be about. How do we go about conducting an experiment and doing stuff like that? So surveys are one. There's a lot we'll have for the rest of the day, but let's get through the steps in this thing first. Once we have this data, like let's say we've asked enough people, then what we're going to do is we're going to use data to develop, it's called Descriptive Statistics. Okay, this will be chapters 2 to 4. And why we call it descriptive statistics is it's information about the group that is used to describe the population. Let me pause. If I get going too fast, someone say something. I gave you guys a second to write that stuff down, and we'll continue. It's a little fuzzy, a little blurry. Why?
It looks okay on our side.
It's okay on your side? Okay.
Yeah.
Maybe it's I need new glasses or something. I got bifocals for the first time. I've never got them. The optometrist recommended it because I'm starting to do this the whole like this thing with books. I'm getting old. I know Ronette in here earlier said I looked 28, but I'm not. I'm not young. I'm getting up there, and so like it ended up being like when I got them, it's like literally the bottom third of an inch of my glasses that is for reading. So I'm trying to look through the bottom of my eyes, and I gotta have like the books like right under. This is not a useful way of reading. Like I have not used the bifocal part yet, and it's not a very big section, so it's like it's not very useful. I'm not gonna get them again because they cost more money. It's lame. If you need this up longer, let me know. Otherwise, I'm gonna pull it in 3 seconds. 1, 2, 3, go. I can always bring it back if you need it. Let me know. All right, so we did step 3. We were talking about descriptive statistics. And so let's imagine I'm going and I'm asking people at the supermarket, would you support paying for a 4-year university satellite campus in town for our county members? And we ask 1,000 people, and do you think we're going to get good results? What do you think the chances are we get good results? Any ideas?
I think a lot of people would be in favor of it.
I do too, and I think in general our results would be fairly representative of the people. However, we just might ask the 1,000 people in the county that are completely against governments or taxpayer spending on stuff like that. So we might get 1,000 no's. Or we might get 1,000 yeses, and neither of it. The county is not going to be 100% in favor of it or 0% in favor of it. So we are not going to hit the exact percentage of Visalia people that want to support it. So it's not perfectly accurate, but we have techniques to make sure that our results are reliable as possible. And so that's what else we do in statistics. It's called performing inference. Perform inference on the statistics. Let's say stats. So when we're in, what inference is we try to infer or describe, as we were saying, descriptive statistics. We try to infer or describe how the entire population would respond to the same question by asking just a few. A sample. I don't want to say a few, a sample. And so there's different techniques to do it. In chapters 5 through 8, we are going to discuss ways that we can do our sampling and stuff like that to make our results reliable. We want to be fairly close. If 68% of Visalians are in favor of the project, we want our results to be somewhere near 68%. We're hoping and by setting up the way we do our sampling approach of the population, most of the time we will get a good setup. And then chapters 9 through 13 will be on the techniques to actually decide whether or not will the population or does the population agree with the research objective, agree or match the research objective. So that our techniques will do that. We will do techniques to see how well our sample matches or agrees with the statement. And if we have a reliable sample, which we do early, we learn, make sure we got a reliable sample earlier, we can find out what the results are. As we were saying, we think a lot of people would be interested in supporting a four-year university. But then again, the people in this Zoom right now are students and a teacher. Of course, everyone here is going to support a university that they don't have to leave home to go to, right? It seems kind of like it makes sense. But not everyone's like, some families are like, nope, school is a waste of time. Get to work. Some families, some people are like, we don't want a big university here. We don't want a bunch of young, people from out of state coming in being crazy. We just want to keep our local people. There's a lot of reasons why they may say yes or no. So we just don't know whether they're going to say yes or no or not. That's what this whole process is for. While we think it will, going out and surveying these people and asking will let us know whether or not they will actually support something like this. And that's what the entire process of statistics is for. So what is statistics? Statistics are a numerical summary of the data collected from a sample. That's what statistics are. If I go out and ask 1,000 people what they say, giving someone a report of yeses or nos, how they responded, or let's go beyond 1,000. Let's say like 10,000 people answer. Is a list of people that said yes or no useful? No. So what we mean by numerical summary is going through and adding up all the numbers that said yes and all the numbers that said no, and that summarizes the population's response to that question. Some things are not always survey questions. If you're trying to, it's not opinion based. If you're trying to find people that are of a certain height or higher, it's a measurement. So you're not asking them stuff. You can just find their height, or ethnicity, or whatever the case may be that you're looking for. It's not always a survey question. So statistics are the summary of the sample. This is slightly different than what we want to know. What we really want to know is called the parameter. The parameter is the same thing but for the population. Parameter is a numerical summary of the population. You get to choose when you're doing a project what your population is, but it should match what you're looking for. Whether or not we want a university in Visalia, we shouldn't just ask Visalians. We should ask everyone in the county. I think people in Hanford and Lemoore and Tipton and Porterville and stuff like that would all love to have a university, or at least some people would, and they would be more than willing to commute to a university in Visalia as opposed to moving to, LA or Sacramento or the Bay Area or something like that. So maybe not just asking, we want our population to be the whole county. If I'm asking a question, I need to figure out something about just students at COS. I could ask students around campus. Well, I probably could before the pandemic. Nowadays, I don't know how representative asking people on campus is. We have a good portion of our students that only come online. So we need to pull people online as well. But if it's the small enough population, I can literally ask or find the answer for every single one. At that point, we don't need to do any of this later steps. We don't need to do techniques or reliability. If we know the entire data's or population's response, we know for 100% what's going to happen. Like in terms of approving a university, if we asked everyone in town or everyone in the county and we had every single person's response, we know right away whether or not it's going to pass or not. That's not practical until you're actually trying to pass it, though. So that's where we're skipping around it. That's why we do this sampling. And the data is just can be too much. If picture the census, you're asking who lives here, how old are they, what's the income, are you religious? They check on ethnicity. What else do they check on the census? They check other things. They ask just a lot of stuff. There's a lot of data collected, and so having these summaries is much more useful. And that's why we use statistics. So if I want to collect information about a group, we can break up that information into two categories. So, categories of information. We have qualitative data and quantitative data. And if you need that other sheet back, let me know. I'll bring it back. So what's the difference here? Well, let's look at the words. It's an easy way to remember is look at breaking down the first part of it. What does qualitative, the word qualitative, what other word does this look like?
Quality.
Quality. This looks like quality. What about quantitative?
Is it quantity?
It's quantity. That may be a word that you're unfamiliar with. If you are, quantity is like an amount. So a number. It's a number. Quality, it still looks fuzzy to me. Let me check the focus real quick.
It's clear. It's clear on this end.
Okay. All right. Quality is more like a trait. Trait, characteristic. So does someone possess a specific quality? Do they possess a specific trait? Another word for it is attribute. These can include numbers. Can you think of as like a numbers that are used to describe people that are not really an amount of something? Like if we had weight or dollars, that's actually an amount, something we can count up. Are there numbers associated with people that don't have anything to do with an amount?
Can you repeat that again?
Yeah. Like quantitative, there are numbers that I can use to describe me that are an amount. I can describe my height. I could describe my weight. I could describe my income. These are all things that I could measure. There's an amount associated with them. But there are also numbers that are associated with me that you can't count. That they're associated with me, but they're not something that it's not like something you add up. What kind of numbers do we associate with people that we don't add up?
Would it be age by any chance?
Age
Or
is
would it
something we could add up. We could find the average age. I like where you're going though.
what about
What other numbers do we have that are used?
A lot of times we use numbers to describe like ethnicities or like races.
They do use. I've seen on surveys they do that. That is a good example. Let's see. If you've ever had a job, what do you have to give your employer?
Oh, a social security number.
Social security number is a great example. If we group them like ethnicities by a number, we could do that as numerical. But we don't really need the numbers there, do we? We could have just say Caucasian, Latino, stuff like that. We all have area code. We're all on the 559 area code, right?
yes?
Area code is a number, but like, does it make sense to add up area codes? Can we get the average area code?
No.
Does it mean anything?
No.
No, it doesn't mean much. Zip code kind of falls in this category too. What ends up being the difference here for the numbers over in this column, they have to be a number specifically. These don't have to be a number. Quantity has to be a number. You have to be able to do math stuff with them. Do arithmetic. Add, multiply, divide. Dividing is getting an average. So arithmetic or math. And so this category actually falls into two groups here as well. We could have a discrete group or discrete quantity, and we could have a continuous quantity. The difference between these two, discrete is something you count. You can go 1, 2, 3, 4, 5, 6. 1.75 doesn't make a lot of sense when you're counting. Counting means whole numbers. So whole numbers. Continuous things are something we measure. Height is, we think of measure like a ruler, height, length, stuff like that, width. So distance is something we measure. So distance, we can measure time. I can count seconds. I can go 1 second, 2 seconds, 3 seconds. It is countable. But I can break down seconds into milliseconds, hundredths of a second, thousandths of a second, billions of a second. Stopwatches get super like crazy. So we can always break it down into a smaller number, and it's something we measure. How long does it take me to get to work? I can measure that with a timer. Counting it by seconds, I'm probably going to arrive in a partial amount of seconds. So there are things like that that fall in that category. Let's see what else I want to bring up in this section. Oh, weight is another thing that we measure. Not just of people, but of objects and things in general. So those are like ideas of continuous measurements. Discrete measurements are things we count. Time includes age. Things we count. I could count the number of students in my class. I can count the number of students that attend COS. It's a large number, but it is something I can count. And it doesn't make sense to have a partial person. I can't say I have 2.6 students. Doesn't make sense. If I've got 0.6 of a student, someone's probably dying. They've something weird. So having partial number of students doesn't make sense. It's something we count. The hairs on my head, I could count them. Probably not by hand. I would probably have to shave and then count the hairs one by one with tweezers. It would take much longer than it's even worth. I can't imagine why I would want the number of hairs on my head, but it is something I can count. It's not something I measure. Let's see, I got something in chat. Calculating our GPA is, GPA comes in, the GPA, the grades you get is, God, that's a tricky one to say. There are only fixed number of grades we can assign you. I would say your grade is a quality or a characteristic. When we're calculating our GPA, we are taking a numerical summary of those qualities. If you get 3 A's and a B, that's what you get. When we do GPA, we assign numerical values to those, and find an average to go, okay, what's your average grade? So GPA is actually a statistic or a parameter about an individual. It's not something I guess it is something we could collect. And since we only report it to 2 decimal places, I would say it's discrete. Money, even though we break down dollars into cents, so I could have $1.59, 1.59. It's still discrete because if I didn't use dollars as the basis, if I just used pennies, I could have a countable number of pennies. And I should show you my change jar that I have in my room. It's one of those big coffee can things filled with nickels and dimes. And they don't even have change machines anymore. I got to roll them one of these days. Makes me angry. So GPA is something we calculate. It's a summary. Other traits we could have, since I just said traits or characteristics, why don't we put some things in this list over here? Hair color, eye color. Do I wear glasses? gender, and that brings up a whole new topic in today's world, but we'll get into that later. What do we do when we're doing questions about gender? Let's see. Level of education. Students are in what grade level? You say 8th grade, 9th grade, freshman, sophomore, junior, senior. They're all considered a trait. Other things that are countable: number of children, income, stuff like that.
Professor Jones, earlier you mentioned a parameter. Could you kind of describe like how to differentiate a statistic and a parameter?
Yes. A parameter, they are the exact same thing, but describing different groups of people. The parameter applies to an entire population. Statistic applies to a group of that population, the sample. Generally, we never have the parameter. If we had the parameter, we wouldn't have to do this entire process of guessing what the population is going to do. So the statistic is the same thing, but it's for a group. So we get a numerical summary like GPA. GPA is a great example. I could get the GPA of my students, and I could try to determine what the average GPA is for all of COS. Now, this semester, I've got in my stats courses, I think I have 121 or 122 different students over 3 courses. And I'm also teaching Calculus 3. And I have, I want to say 35 students in there. So I might have 150 to 160 students this semester, somewhere in there. So I could get a GPA from my students and try to apply or try to figure out what range the population might be in. So like if I surveyed my students and the average GPA, let's say it's 2.9. Then I go, well, if my students have an average of 2.9, what range of numbers do I think the population is in? Maybe 2.6 to 3.2? Maybe the average is in there. So that's the difference between statistics and parameter. Statistics is just for the group you ask. That's usually what we're acquiring because we don't have the parameters. Like I said, when ballot time comes and everybody answers whether or not they approve the university thing, we know the answer to whether or not we're going to have the university. It will be funded or it won't be funded. That's because we've asked everyone in the county to come vote, and everyone votes or chooses not to vote. And by not voting, it's a choice. We will have a count on whether or not it passes. Before then, it's when we ask just a group of people, like the people at the supermarket, it's just a statistic. Does that help?
Yeah, that does a lot. Thank you.
Okay. So once we've collected all this data and we did something like that, I'm going to go with that GPA thing. Let's go with the university. I'm going to go with the university because that's the one I started with. Let's say this is an example of what I would do. I think, and I just randomly chose 68% earlier, and I'm going to stick with it. I don't know why. I don't know if it's higher or lower, but I'm going to go with this number because I have no idea. I think 68% of Tulare County would support a 4-year college, university in the county. I go out and ask people. And I have a couple possible outcomes. One possible outcome. I get a number that's close. The other possible outcome is it's not close at all. So to give, like the second one's pretty easy to give. If I ask 1,000 people and only 10 of them say they're up for a university, 10 people out of 1,000 would, if I got 1% that said yes in a sample, of 1,000, I'm clearly wrong. My 68%, there's no way in hell. I just chose that poorly out of 1,000 people and found just everybody in the county that didn't want to do it. So this would be, with the information I've collected, I could refute my claim that it's 68%. Another possible outcome is I get a number that's close. And now we start going with what's close. We could say 67%, 69%. Those are obviously close. Those are just 1% away. Is 72% close? Is 60% close? So at some point, this is where the techniques and stuff that we're going to do throughout the way are going to kick in, and we'll decide if I asked and I got 60% to say yes. Well, in some scenarios, based on what the sampling is and the techniques and stuff that we're doing, 68% is still close. In a lot of examples, 8% away isn't really that close. In terms of this, what I want for this ballot, though, what I'm really trying to go is, will more than 50% support it? So here it would work. But if I wanted an exact percentage, 60% might tell me 68% is way off. An example of where that percentage matters is milk fat. 2% milk fat. Low fat milk. Well, they try to get it where it's low fat milk. They only 2% milk fat in the milk. How do they do it? They sample different quarts of milk, different cups of milk, and they find the fat content in it. What if they get something that says 3% or 4%? What's at that point? 4% isn't really. It's like double 2%. So, like, depending on what we're looking at, 1% may not be close. It may still be far away. And we're going to go over in the course of the semester looking at that kind of stuff. What makes a number close enough? But the question is, if it's close enough, I can support my claim of 68%. By doing this is what we call statistical analysis. And that's the entire point of this class. We have an idea. We don't know if it's right. We think we know, but we're going to go out and collect data on it. It's not always people. You're not always asking questions. You're going to collect data on it. You're going to take a summary of the data. Maybe we're talking about how long it takes for cars to brake from 60 miles an hour down to 0 if the brakes are fully depressed. Does it take 3 seconds? Does it take 3.6 seconds? Does it take 1 second? We want to find an average number of seconds a car brakes. That's not something you can ask. It's something you have to experiment with. But we will get the numbers, and each car, individual car, would have a different braking time, just as each individual person is going to have a different response. But we collect the data, we get a summary of it, we analyze the data, and we decide whatever question we were asking in the first place, is our hypothesis realistic? I hypothesize 68% of people want a 4-year university. So that's kind of like what we're doing in this course. The whole point of the course. Okay? You guys ready for some more, or you guys need a break?
You can keep going.
Keep going? All right.
Yes.
That was kind of like 1.1. If you're in my class, and most everyone in here is in my class, my homework in math lab or stat lab is grouped by the entire chapter. Ronette, you're with Miss Collier. I don't know if she does it by chapter or by each section. So that was section 1.1. 1.2 is on variables in statistics. So let me just give you an example of what they are. Not an example, just tell you what they are. We'll use an example and we'll say which is what, which is which. Generally, there's a cause and effect. Those are the words that are not stats related. The stats related thing is if we have a variable that is a cause in something, we call it the explanatory variable. Why did an outcome occur? And the effect is called the response variable. What was affected? Or what was the result? So I'll give you an example. Let's give you a scenario. Let's say a survey was conducted. On teenagers. What? On, it might be the bad word. Let's go with teenagers. With teenagers to see if owning a mini fridge in the bedroom leads to obesity. Give you a second to write that down and try to think about it. What you would say is the explanatory thing here, and what is the response? Give yourself a little bit to think about it, and then we'll describe it together. What would they have to ask the students or teenagers in the survey?
I would say, what is your focus on the refrigerator in your room? Like, what do you mainly want it there for?
Okay, that's a good question. What is the fridge for?
Like, what is your main purpose of, wanting a refrigerator in your room?
I love where you're going. That is going to lead to my very next idea. But in terms of cause and effect, what am I trying to say? What is the mini fridge in the bedroom? If they even have a mini fridge, what would we say that is? The cause or the effect?
I would say it's the cause of the obesity.
It's the cause, right? So the surveyor is saying owning a mini fridge causes it. Causes an outcome.
Right.
What outcome does it cause? Obesity. Or not obese. So 2 questions they would ask is, do you own a fridge? And are you obese? They may not ask, are you obese? They may just ask, do you own a mini fridge, and decide for themselves, looking at them, if they think it's obese. Let's see, someone's chatting. Yes, thank you, Natalie. That's exactly it. The weight being affected is the response. The mini fridge is the explanation. And so where you're going with the what is in the fridge, well, now you're asking another question. Like, where were you going with that? Why were you asking that question? What was your thinking pattern with that question? Because it's going to lead to the next idea.
Basically, what I was trying to say is, are the teenagers focused on filling the refrigerator up with goodies and things like that, which would cause them to think about it all the time?
Is it goodies, snacks?
Yes, snacks.
Or, soda? Or
Soda,
is
candy
it
bars,
fruit and water?
candy bars, soda.
Yeah, so what's
sour
going in the
gum.
fridge? Right.
Basically junk food, yeah.
Right. So, is the fridge really a good explanatory variable? If someone's obese, is the mini fridge the cause?
No,
No.
definitely what's inside of the mini fridge, or basically the way that they're using it.
It's the way they're
And
consuming it. It's the foods they consume. You're right. Foods consumed. Exercise level. Because you could have a mini fridge in your room, but you run 6 miles a day and you're fit as a fiddle, I think is the expression. Exercise left. What the hell am I writing here? Exercise levels. Genetics come into it. Some people are predisposed to, they don't have good digestive stuff like that. What's the word for it? Oh my god, I'm drawing a blank.
Fast metabolism.
Metabolism. That's the word I'm looking for. Thank you. So genetics, metabolism. That's exactly the word. So there are other things here. These other things here are called lurking variables. Lurking variables could be the true cause. Oh my gosh. Could be the true cause of the effect, whatever that may be, in this case, obesity, but are not looked at in the survey. So they're kind of like lurking in the background. Lurking is always something that's described as something, usually somebody or animal or person, creeping, sneaking around in the shadows. That's how a lot of predators hunt. They lurk, they sneak up, and then they charge pounce. But they're not in sight the whole time. That's what lurking variables are. They're not in sight. They're not being asked about. So this survey may not be a very good survey. Well, how could we modify that? Let's take a look at like, what do you guys think we could do to change this survey? How could, rather than just asking mini fridge and obesity, what else could we ask? So right now we
Lifestyle,
have, let's put what we have. Do you own a fridge?
stress
And
levels.
say that again.
I said lifestyle, stress level.
Okay.
How about how often you open the fridge to get a snack?
Frequency of use of fridge. That's a good question. We already said one of them. What are you putting in the fridge? Are you putting snacks and candy bars and sodas in the fridge, or are you storing fruit and healthy things? So maybe contents in the fridge. Let's stop with that, because this we're not. I want to stop before we have a perfect survey. So here now we've got a couple things that we're talking about. Well, here you're narrowing down the fridge. Let's do stress level, lifestyle stress level counts. Lifestyle, let's say that includes exercise in it. Stress level is good, but no one's ever said stress level before. There's stress eating is a thing. That is not a joke. So now, if I ask this question, what possible causes? We still have obesity as the effect. So that's our response. What kind of possible causes are we getting for the obesity in this survey? Our explanatory ones. One of them is still the fridge, right?
All right.
One of them is lifestyle stress. I'll put exercise as maybe a third thing there. Lack of exercise could cause obesity. When we have more than one explanatory variable, but that isn't really separated enough or something like that, this is called a confounding variable. This is all lingo. The homework stuff will ask you the lingo on confounding every once in a while. They'll ask you definitely in chapter 1 about confounding and lurking, stuff like that. It's important you know that, because knowing about these things makes you create a better survey. You got to think about this shit when you're making a survey. You want the survey to be good. If you don't like cussing, I apologize. I do cuss on occasion. So confounding. And the idea with confounding is, how do we know which is the real cause? So you want your surveys to be done pretty well. And they generally take their time and think about all the different ways before they send out a survey if it's really important. Okay, so there's a couple ways we can experiment here. If you need this up longer, let me know in the next few seconds and I'll leave it. Otherwise, I'll move on to the next idea. Okay. So what are the different types of ways we can do these experiments?
Could we go into like gyms?
We could. What would we do in a gym?
We would interview different people on
So
different.
asking questions, right?
Yes.
Okay. So when we're doing that, what that is called is an observational study.
Okay.
And observational has the word observe in it. Like watch or see. And when we're observing something, we're generally not trying to sway the outcome. So in an observational study, we measure the response. In this case, the answer to the questions. Without attempting to influence the outcome. I don't think an observational study would work very well with this type of question. If we're trying to figure out if owning a fridge, mini fridge for teenagers affects obesity level, there's just too many other elements in play, right? Their activity level, what they've got in the fridge. Just asking isn't good enough. So if I wanted to do this, I would probably do something called a designed experiment. In the designed experiment, individuals are assigned to different groups. And the explanatory variables are controlled. Or intentionally changed. Now, this doesn't sound very ethical with the survey with teenagers. Do I want to take a bunch of teenagers, give them all a mini fridge, give half of them a mini fridge, half of them not a mini fridge, and then maybe in each mini fridge, like half the mini fridge owners half of them get fruit, half of them get fruit and water, the other half gets, candy bars and soda. And then I do the same thing with the people without the mini fridge, but it's in their main fridge in the kitchen. I could design this type of experiment, but I think I'm kind of like, if I think it causes obesity, I'm kind of like setting up these students or teenagers to become obese by doing that. So I don't know if it's a very moral thing, but we could do it. Another scenario where this designed experiment comes up is with experimental drugs, medicines. Now, they can't, like when they think they have a cure for something, they go out and get people that whatever they're trying to cure, they get people to try it. But there is something called the placebo effect, which surprisingly works more often than you think it should. If you think you're taking a cure for something, your body gets better. Now, in some cases, this clearly isn't going to work. Like, cancer shouldn't go away if you just think you're taking medicine for it. But in some things, it does work. So they do controlled studies when they're doing it. They will make two groups, and one group knows, they all think they're taking the pill or the drug, whatever it is. If it's not a pill, the injection, whatever, the cream, the ointment, the lotion. And then the one group is actually getting it. The other group is getting something that looks, tastes, feels, whatever, identical to the other one, but is missing the actual drug. It's called a placebo. So they swallow a pill that looks like identical to the pills that the other group is swallowing, and they both groups think they're taking it, and then they measure how effective the cure works in the two different groups. So this is intentionally assigning individuals to different groups and controlling the explanation of the cure. Like, are they cured? The explanation being medicine or not medicine. They actually control it with the group. That's what a design experiment is. So the explanatory variables are controlled, and how do we find out if it works? Their responses are recorded. In the case of medicine, did they heal? If it was a weight loss thing, how much weight did they lose? If it was a quit smoking or quit drinking pill, how effective is it? Do they still want to drink? Are they still smoking? So between these two, the designed experiment is the better choice. And the reason why is we can explain the cause by controlling the different things. This is called causation. We know what caused it, causation. If on the observational, we cannot get causation. No causation can be determined. If I ask 150 teenagers if they own a mini fridge, or ask 150 teenagers that own a mini fridge if they're obese, I still can't determine if the mini fridge is the cause. What I can determine is called correlation. Correlation is when things match up. But one does not cause the other. And I'll give you a good example of this. I like this one. Guess what? Let's go with July. In July, ice cream sales are way up, and crime is way up. So, example. In July, ice cream sales are up. And crime goes up. Do ice cream sales cause crime?
No.
Does crime cause ice cream sales?
No.
No. No for both. There is no causation here. There is only correlation. They're both going up together. There's a correlation between those two things. What is going on here? What's July? What might make this happen?
Weather.
The weather.
The weather.
Very much the weather. It's the heat. Heat makes ice cream sales go up. I don't know why, if it's necessarily heat or time of year for crime. People might just be like they want more ice cold beer and they're out stealing shit or more, or they're hotter and they're more irritable, so they get more fights, or they're only busy during school year, like teenagers and stuff. They're busy during the school year. They don't have time to get into trouble, but in summer they have summer off and they can get into some shenanigans. Whatever the case may be, crime does go up in summer. I don't know why, but ice cream sales do too, and so there's no causation, just correlation. The study with the medicine, as we said, medicine is causation. They do the designed experiments a couple ways. So it might come up. I want to just tell you about it in case it does. Let's see. Let's get this so I can. There we go. So a couple ways you could run that design experiment is, so we've got the drug and placebo. To two different groups. The groups never know. What they are getting. They may not even know there's a placebo group out there. If you're not in the know, there's no reason to think that they're going to give you a fake pill. This seems pretty fucked up. If I had cancer, I don't want to be in the goddamn placebo group. I want to take the experimental drug. If my life was going to be, if it's no other cure and that we think this might work and I'm going to die soon without it, don't give me a sugar pill. Give me the thing. But they can't tell you. So each group, and they have to do this to make sure that the drug actually works. It's part of FDA and whatever FDA FDA does drugs also, doesn't it? Yeah. The groups never know what they're getting at, but people are giving them drugs. So if the group manager, let's call it that, the person giving the pills, or pill giver, if the pill giver doesn't know, or let's go with does know what each group is getting, this is called a single blind study. If the pill giver doesn't know, it's called a double blind study. Any particular reason you could why we would want to do a double-blind study over a single-blind study? Can you think of?
A lot of times the data collection method could be affected. So I guess maybe how often they take the record data, or even the population selection
Could be.
or sample selection for the study could be affected.
Definitely. They try to, in most cases, they try to make sure the pill giver is not the person that makes the groups. But in some cases, yes. If you were giving pills to a group of people and you knew you were giving cancer patients a pill that doesn't do anything, it's a sugar pill, do you think you might accidentally tip them off?
Most likely.
Probably. If you knew you might be unhappy, you might look sad because you know that there's likely not going to recover. You know your group is suffering and you're getting to know them, it's bad. You might tip off the group, and if the group knows, it ruins the entire experiment. The placebo group cannot know they're getting a placebo. It's doable in a single blind study if you do it the right way. You just got to make sure the pill giver isn't interacting with the recipient. Like if they put it on the counter, they leave the room, the other group comes in and gets the pills and takes them. So there's no interaction. So it's possible to do it, but it's easier just if the person doesn't know. Let's see what else we got here. Some other terminology we use in this stuff. We could do a cross-sectional study. And the infos could be collected at once or over a long period of time. If you were doing a weight loss drug, you'd probably weigh their weight every week or something like that. It'd be over a long period of time. But it's done in the here and now. It's current. Whatever you're doing it currently. We also have like the case control study. And this is more of a retrospective or long-term thing. Did you used to smoke? For non-smokers, did you used to smoke? We're asking them to think back or analyze their life retrospectively to find out whether or not they ever smoked. And it might be we're trying to explain some effect on maybe lifespan or weight or some form of health thing. Or do you drink alcohol or did you ever drink? Have you used drugs? Did you ever use? So one would be current, but the other is looking back. We have cohorts. Where a group is studied over a long time. This is definitely the case with the cross-sectional thing where I talked about the weight loss. We have the same group of people taking the weight loss pill, and we're studying them over a long period of time with frequent weigh-ins. But it's the same group. The group isn't changing. If the group changes, it's not a cohort. Some other terminology you'll see used. I've actually used one of them already. A census. We talked about this with the US Census. A census is the list of individuals in the population. And their characteristics. I should have done this in the other order because a frame is just the list of individuals. No characteristics recorded. I will probably never use the word frame ever again in this class. Why? I don't think it's a good word. I don't think other people use it as often as it. To me, a frame is a border on a picture. That's what a frame is. If I want a list of individuals, I just call it a list of individuals. Why would I use a word that I just associate with pictures? So I wouldn't call it a frame, but that's the official lingo. So if they ask you about it in homework, that's what they're talking about. Any questions on that so far? Almost done. We're going to do 1.3, but 1.3 is pretty quick. If you need that back, let me know. I'll put it back up. 1.3 is on the simple random sample. And I think the best way to describe a simple random sample is to give you examples that are not. If I want to find out if the population thinks that exercise is important to a healthy lifestyle, should I survey people at a gym?
No.
No. Everybody at the gym should be, I'm pretty sure I'm going to get a 95, if not 100% answer yes. Exercise is good. Asking at a gym may not be the best spot to ask. Why? It's not random. I'm picking a targeted group of people. So when we want a random sample, we want it to cover all the different types of people. I'm using the word people, but whatever the thing you're studying, cars or whatnot. In the population. This is very important. If I'm only surveying, if I'm asking a question that's only related to students, asking the general public is not really a good place to ask because a lot of them aren't students anymore. Asking at a school is a good place to ask. So we want to cover all the different types of people in the population, which means we have to hit different areas or different things like that. We also want it to be random. We don't want to ask every single person. So the idea of a simple random sample, things we could do, some good examples are, let's say we're trying to find out information about students. Let's say it's back to pre-pandemic. There's not very many online classes. And we're on campus. I could stand outside the library and I could ask every fourth or fifth person walking in the library, do you have a second to answer this survey? But if I just do it on like on mornings, if I go up Monday, Tuesday, Wednesday, Thursday, Friday morning, I do it for 2 weeks. I'm out there from 9 to 11. I may not be getting a good random sample of the people because I'm only asking people that are on campus in the morning. So you may want to do it as well at night. Do some surveys at night. You may not want to just ask in front of the library. Do it near the cafeteria where you get a different group of people. Not everybody goes to the library to study. People that go to the libraries to study tend to have specific study habits. And if your question's on studying, and it might be because you're asking students, maybe not just asking people that go to the library is good. We could walk into random classes throughout the day on different spots on campus and ask different people in the class to take a quick survey. That would be a way of getting a good random sample. Let's see. And what's wrong with doing the library thing? If I just did library, let me write this down. I'm not writing as I'm talking. Let's say we are asking students. Questions. And my idea is go to the library from 9 to 11 a.m. and ask there. What's wrong with this is it's called, or as a student might do this. As a teacher, I ask only my students. Ask or sample only my students as a teacher. This is called a convenient sampling. It's convenient to whoever's asking the questions. Not having to be in front of the library all day is pretty convenient, right? Not having to go into other classrooms and ask questions as a teacher, just asking the classes I have, that's pretty convenient. This could be a random sample or yield a random sample or good sample. But there's no guarantee that it does. In fact, I would argue that this semester it doesn't. For me, if I were to sample my students, I'm only teaching online, I'm definitely not getting a good representative group of the representative sample of the COS population. I suspect a lot of my students work during the day or have busy schedules, and they took online classes because it fits in their schedule a little bit more conveniently than a traditional student that's on campus and has time to go there and be there 8 hours during the day. So me sampling my group may not work. If I had both online classes and face-to-face classes, it might work. I might get a good sample, but I definitely would not right now. So when you're doing a simple random sample, you want things to be random. Don't try to ask every person. Maybe pick a number and go that many people. Every seventh person that passes you. It's like if you're surveying, as soon as you're done with one person, don't just grab the next person that walks past you. Wait a couple people, ask them, and then ask them. Don't try to ask every person. Try to capture the population by doing it at different times and places. What else do I want to say about this? We're going to cover biases more in the next section that we'll do on Thursday, which is 1.5 that we're going to do. Convenience sampling is actually in there. So I don't want to get too far ahead, but you want it to be random. If you're trying to pick random numbers, oh my God. Okay, so there's going to be, and I hope it's not in mine. I haven't checked. I might have to go through and delete it. In some of the stat lab problems, they give you a grid of numbers, and they give you this cockamamie routine of picking random numbers from that table. And it's a terrible, terrible, terrible approach that no one would do ever, at least in the last 30 years, because we have too many ways of generating random numbers that don't require it. But for now, in general, if you want a random number, there's a lot of apps on the phones that give you random numbers. You could do it that way. StatCrunch, which is going to be our statistical software that we use, starting in chapter, I don't know, is it chapter 2? Yeah, starting in chapter 2, we're going to start working with StatCrunch. It does stuff, and it can generate random numbers. Rolling a dice, a single of a dice is a die. Rolling a die will give you a random number. The most common dice that you're familiar with are 6-sided dice. They have 6 sides. But there are dice that have 4 sides, 8 sides, 10 sides, 12 sides, 20 sides. And they've made some really weird ones that you can have a side that has 5 and stuff like that. So they got some weird shaped dice that you can generate random numbers with, but most times it's just the phone or using an app. Hey, Hansel.
Hey, Mr. Jones.
So you're going to do stuff like that to get a random number. In terms of getting random people, ask people randomly. Ask people at different times and different locations. Try to make your survey around avoiding any biases that you can, which we'll cover on Thursday. And I think that wraps up what we're going to do today. I think Hansel just showed up. It's bad timing. Is there any questions on what we've done today? This is 1.1 through 1.3. You've seen this part before, Hansel, though. I know you have.
It's been like 4 semesters, but okay.
We haven't done any math today. Would anyone say we've done any math?
No.
Is there anything that you could even remotely describe as math so far? We've just talked about how you survey people, right?
Yeah, right.
Okay. So if you don't have any questions, I'll
take their word.
Stop recording. And then if you want to stick around, if you have questions, I'm sure Hansel's going to ask me questions right now. You can stick around. So what kind of questions do you guys have? So far.
For the homework, do we do that on Thursday because that's when we finish the chapter, or?
You can start working on it now. For my class, let's go look at, this will be every student except Ronette is in my class. Let's go look at an example. We are going to finish chapter 1 on Thursday. The homework will be due Tuesday, September 6th, which is 2 weeks away. And we start having due dates. I want to give you, every time I want you to have at least a full week. And I set it to be due during the, on Tuesdays at midnight, so that if you were working over the weekend and you had questions on Monday, you could easily get a hold of me. And by making it at midnight, if you have questions on Tuesday before class, come to office hours at 5:30 to 6:30. I can answer them there, and you still have time to fix the homework before you submit it. But you can start working on it at any time.
Okay, thank you.
Uh-huh. Oh, I see a typed question. You're welcome, Ronette. I'll talk to you later. Any other questions for my students? Or anybody about this, what we've done so far? Yes, Hansel.
What exactly did I miss?
We did 1.1, which was on what the hell is statistics? Why do we do it? I hope you remember that part. We're trying to figure out information. We want to know something without asking everybody in the entire population. And how do we go about doing it? We sample groups, we ask questions, stuff like that. In 1.2, we talked about what types of things the questions are. Are they cause or effect? Like having a mini fridge, does that lead to obesity if you have it in the bedroom? There's weird questions out there.
Yes, there is.
I guarantee you, look up. Oh shit! Let's see. Let's see. Weird studies. God, this should be good. Oh wow, that's actually a place. The 10 weirdest science studies of 2019. That should be good. Loch Ness Monster DNA. Would a knife made from poop work? Maybe. Are there plants that eat salamanders? Can your tongue smell like your nose can? Oh, I want to say there was one I saw on Colbert or John Oliver something recently that pigs can be, was it fed or hydrated, kept oxygen. You can cut off a pig's oxygen through its nose and give it oxygen up its butt, and it will give it enough oxygen to sustain its life. So it didn't need to go through the lungs. What the fuck? Who decided this is a good study? Like, why? How much money did you spend on this study? That was a recent one. What other? So,
oh my god.
But vampire tree, that's good. A sound so loud it vaporizes water. That's actually kind of cool. Because we think of heat vaporizing water, making it into steam. Can a sound be loud enough that it actually makes water turn into steam? I don't know that that's a useful study. But it sounds kind of
cool. Regardless, it's a study.
It's a study, yeah. So there's lots of studies out there. Some of them are good, some of them are bad. On almost every single one of them, there is a cause and there is a effect. In this one right here, decibel level of the sound is the cause. Is the water vaporized the effect? So explanatory variable versus response variable. We talked about different ways that we can do surveys. Do we just ask questions like observe? You don't even have to ask questions. You can observe and figure out someone's height and stuff like that, or hair color. I don't need to ask you your hair color if I can see your hair, right? I could just write it down. So I don't even need to ask a survey. But there's other ones that are designed experiments rather than observational. And then we talked about being random in our sampling. That's pretty much it. You didn't miss a lot yet today, Hansel.
Any due dates for well, I know they're going to be due dates, but due dates for the Math 321?
Tonight at midnight is the cutoff when everyone can sign up. I am going to tomorrow morning at I teach from 8 to 9, but at 9 a.m. I'm going to start assigning due dates. and they'll be in there at least a
Sweet.
week ahead, and they're staggered over the next 7 or 8 weeks till the midterm.
Sweet. Okay. You're gonna be going to campus at all, right? Like, going to math lab or anything?
No, but
That's
you can always ask me about or ask to Zoom with me all the time. I mean, I could.
yeah, for sure.
You see what I'm doing right now. I can show you what I'm working on.
For sure. For sure.
So we can simulate being sitting next to each other.
Sweet.
And since you can share screen, if you're working on homework, you can show me your homework problem that you're working on. Going, I don't know what the hell this is. So this will work. In fact, in some ways, better than on campus because you can show me what you're doing at your leisure. You
Yeah.
don't have to leave home to do it.
When you put it that way, yeah, you're right.
Right? So it's pretty good that way, doesn't it?
Sweet.
All right.
All right. I guess I can start on the homework then.
Yeah. And I'm gonna, as soon as this video is done recording and rendering or whatever the hell videos do, I will upload this to YouTube. But there's 2 of them already up. They're all the same. This one today I used a different topic than I've done previously. I've done pandemic questions before. Today's question that we looked at was, I know the university or the college has bought like the apartments to the south of the campus, the COS campus, and they're going to try to make it into a university center for Fresno State so
That's
we can
awesome.
have some 4-year degree programs here. And they're going to ask the taxpayers, will you fund this through some bill or measure on a bill soon? So that was our topic. What do we think people will, how do we survey for that kind of stuff? So things like that.
Sweet. Okay. Right on. All right, Mr. Jones. So same time again, Thursday, right?
Yeah.
Awesome. Okay. Well, I'll keep in touch and I will see you Thursday.
Okay. Peace.
I have a question.
Yeah.